Okay, this video accompanies the 6.6 Student Companion Notes, Conditions of Special Parallelograms. Let's get started. Let's see. So these floating lanterns they're telling us on here that all the sides are identical quadrilaterals. So it looks like this is a rectangle. The other side would be a rectangle. And so on. Okay, so how could you check to see whether a side is a parallelogram? So test for parallelograms, what could we do? One thing we could do is to check and see if the diagonals are congruent. Well, if the diagonals bisect, say. Because if the diagonals bisect, it's going to be a parallelogram. Like in a rectangle, the diagonals are congruent and bisect. In a rhombus, the diagonals are perpendicular bisectors of each other. In a square, which is also a rhombus with a right angle, the diagonals are perpendicular bisectors of each other. And in a typical parallelogram, like a general parallelogram, the diagonals are not congruent, but they're bisectors of each other. So that would be probably the first thing you could do to see whether you have a parallelogram, is to see if the diagonals bisect. Another thing I guess you could do is if you could check to see that at some angle the two sides were the same distance apart. That would kind of imply that the opposite sides were parallel. But the easiest thing to do would just be to kind of take a measurement, say from B to D, and then check the measurement from A to C. And if those measurements are the same, well, if the measurements are the same, you actually have a rectangle or a rhombus. But if you measure, say, from B to E and from E to D and find out that E is the midpoint, if you measure from C to E and from A to E and find out that E is also the midpoint of that diagonal, then you have two diagonals that bisect each other, which is a property that parallelograms have. Okay, let's look at B. Does the side appear to be rectangular? Well, it does. How could you check? For this one, since the rectangularity is what we're checking for, we're trying to see if really there's a right angle there without doing a measurement. And if we're just generally checking, in a rhombus, the diagonals are going to be perpendicular bisectors of each other. But in a rectangle, the diagonals are going to be congruent and be bisectors of each other. So I would check to see if the diagonals were congruent. Because if the diagonals are congruent, then you've either got a square, which is a type of rectangle, or you have a rectangle. Now, the only other shape you could have that would have congruent diagonals would be an isosceles trapezoid. So we can kind of knock this one out, and those are going to have congruent diagonals. But those are the three figures that we have that have congruent diagonals. In the first two, they're also bisectors of each other. So we have a perpendicular bisector for the square. We have bisectors for the rectangle, and we just have one pair of parallel sides for the trapezoid. So are the diagonals congruent? That would be a good check. Note C, do you think that the diagonals of a quadrilateral can be used to determine whether it's a rectangle? If the diagonals are congruent and it's not a trapezoid, it's going to be a rectangle. So if diagonals congruent, diags congruent, and The quad is not a trapezoid, not an isosceles trapezoid. It is a rectangle. So let's see. So let's just kind of draw this quadrilateral here. And so what I'm saying, well, you should be checking for it. Now, this isn't a trapezoid. We're actually checking to see if the length of this diagonal is equal to the length of this diagonal. If these two are congruent, these two diagonal lengths are congruent or equal, then it must be a rectangle. Let's move on. Okay, example 1, using diagonals to identify a parallelogram. See what we got. If JHK, so JHK, which is this angle, and JGK, J to G to K are complementary. That means these are going to add to 90 degrees. What else can you conclude about this? About this figure. Okay, so you got opposite sides parallel, so it's a parallelogram. They're not telling us that the sides are congruent or anything like that, so we don't know for sure that it's a rhombus. If these are complementary to each other, let's see. Okay, let's assume that this is a right angle here. Opposite sides parallel. They're not really telling us opposite sides are congruent. But if this is so, and if these two are complementary angles, then this angle here at J is going to be congruent to the one at G, because the angle here at HJL is complementary to this other angle that they gave us at H. And that's the same as being complementary over here at this G. So in a right triangle, these two are congruent to each other, which means that there's a right angle here, or not congruent, they're going to be complementary, and that means there's a complementary angle here, because these two need to add up to make the other 90. These two need to add up to make the other 90 in the 180 that those triangles have. And then what that does is that goes along with the parallel sides, alternate interior angles congruent, parallel sides, alternate interior angles congruent. So these angles are going to be congruent also. And you got the right angle, you got a leg here, and another leg here. So these triangles are going to be congruent by side angle side in pairs. And if they're going to be congruent, we've got opposite sides congruent. So we can conclude that opposite sides are congruent because of corresponding parts of congruent triangles being congruent. And triangle GHL is congruent to triangle JKL. Also, and this is by side angle side, and also these other two triangles are congruent. GLH is congruent to JLK for the same reason. So these two triangles are going to be congruent by side angle side. These two triangles are going to be congruent by side angle side, which means that by corresponding parts, these sides here are going to be congruent. And by corresponding parts here, we have that these two triangles are congruent. And we might be able to go even further than that. Like if we could show that all of these triangles are congruent, they've all got the same. Let's see what's going on with this one. If this is a 90, okay, this is a 90. By alternate interior angles, this angle and this angle are going to be congruent. Yeah, by with alternate interior angles and the parallel lines, basically we can have that all of these triangles are congruent to each other by side angle side, since they all have combinations of the same angle pairs. And then that lets us know that all of these sides are congruent, which lets us know that GHJK is a rhombus. Since all sides are congruent. We can say that it's a rhombus, that this parallelogram GHJK is a rhombus. Okay, let's move on. Example 2. Show that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So let's see. So we got a parallelogram here using alternate interior angles. With the parallel lines, we actually have that angle 3 is going to be congruent to angle 2 also. And going the other way, we've got that angle 4 is going to be congruent to angle 1 also. So angle 3 is congruent to angle 2, that's a double marked one. And angle 4 and angle 1 are going to be congruent to each other. So by alternate interior angles, angle 1, 2, 3, and 4 are all congruent. So with the parallel lines, cut by transversal, alternate interior angles are congruent. So angle 3 and angle 2 are congruent. And then by alternate interior angles going this way, we got angle 1 and angle 4 congruent. And then in all the different combinations, basically they're all congruent to each other. Let's look at example 3. If the diagonals of any quadrilateral are congruent, is a quadrilateral a rectangle? Now, talking about any quadrilateral. One special case is an isosceles trapezoid. In an isosceles trapezoid, we have congruent diagonals, yet it's not a rectangle. Otherwise, if it's not a trapezoid, if it's a parallelogram, so if a parallelogram, which the trapezoid is not, then congruent diagonals point to it being a rectangle. So that's the thing to watch for. If it's an isosceles trapezoid, which only has one pair of parallel sides, so it's not a parallelogram, that has congruent diagonals, but if it's got congruent diagonals otherwise, it's got to be a rectangle. Because those are the other parallelograms that have congruent diagonals. Let's look at example 4. Okay, we want to come up with a special name based on what's going on with these. So here we got that these two pieces are congruent to each other, but there's nothing about bisecting going on. So the sides obviously don't look like they're congruent, and there's not enough information to say that they are, so it's not a rhombus. The opposite sides aren't congruent. It's not a square. Could this be a rectangle? It could be a rectangle. By vertical angles, those two angles are congruent. but there's nothing about this being the middle of GJ or the middle of HK. There's nothing about the lengths of the diagonals being congruent to each other. Now, if they meant by this mark that the whole diagonal is congruent, like if HK equals GJ, then it's a rectangle. Otherwise, not enough information. Okay, let's look at this next one. Here they're showing us that this diagonal bisects this top angle. It's a parallelogram. Oh, well, now let's go back to this one. It's a parallelogram. So let's put the parallelogram stuff in for A here. Now, if it's a parallelogram, by alternate interior angles, we've got these angles congruent. By alternate interior angles going the other way, we have these angles congruent. We got side, angle, angle. So by angle, angle, side, these triangles are going to be congruent. By side, angle, side, these are going to be congruent. So let's see. So bringing that back into play here, with this triangle 1 being congruent to triangle 2, these two sides are congruent to each other. Now that doesn't mean necessarily it's a bisector yet. But those two sides are going to be congruent because these are corresponding parts of these two congruent triangles. Let's go for these triangles. These two triangles are also congruent by side, angle, side. That means that these corresponding pieces are all congruent. So basically, we can think of them all as having two hash marks, which does make the diagonals bisectors of each other. And also, it makes the diagonals equal in length because this is made up of two sections that are the same length. This is made up of two sections that are the same length. So it is a rectangle. And we basically, through this argument with these congruent triangles, gotten that HK is equal to GJ because of the two congruent parts. So yes, there is enough to say that it's a rectangle. So let's see what's up on this one. So this is a parallelogram also. So I'm going to label the parallel sides, opposite parallel sides. By alternate interior angles, these two are congruent. By alternate interior angles, this one also is congruent to this angle here. And so we have these triangles congruent to each other. Let's see. So we got the bisector thing going on with the diagonal here. Side, angle, side. Let's see what else we got. The alternate interior angles, we can get all these other angles in here too. So angle, side, angle, angle, side, angle. It's going to let's say this is a bisector. That's going to let us, because with these two triangles being congruent, sharing this common side, and an angle here and an angle there, this is going to be an angle, angle, side pattern we could use to say that these are congruent. Same thing over here, we could do an angle, angle, side pattern to say that these are congruent, which basically is going to let's say that X is the midpoint of TV, and X is also the midpoint of UW. So we have two diagonals that bisect each other, and their sides are all congruent. That's enough for this to be a rhombus. So number 5. In parallelogram ABCD, what must be true for it to be a rectangle? So let's look and see. So we want to sketch ABCD. AC is 3 w minus 1, and BD is 2 times w plus 6. Now, if this is a rectangle, those two diagonals are going to be equal to each other. So I can set them equal to each other in algebra. This gives me 2w plus 12 with the distributive property on the right. Has to equal 3w minus 1 on the left. Take 2w away from both sides. We have w minus 1 equals 12. Add 1 to both sides, w equals 13. So if w equals 13, AC is going to be congruent to BD, and parallelogram ABCD is a rectangle. Let's look at the next one, number 6. Okay, here we have some angle measures. So we got 58 and 58 and 32. So that these are complementary. They add up to 90. So that tells us that there's a right angle there, which means that these are all right angles. If this is a 58 and this is a 90, complementary means this has to be a 32. And let's see, it's a parallelogram. So these angles are going to be congruent. This angle here is going to have to be a 32. And so that means this is going to be a 32. And then by alternate interior angles, this is going to be a 58. And going the other way, this is going to be a 58. So all 4 of these triangles are congruent to each other, which means that all of these opposite sides are all congruent to each other since those 4 triangles are congruent. And we have a rhombus. So yes, it is a rhombus because, as explained, because all sides are congruent. Also, we can see that the diagonals are perpendicular bisectors of each other. And what else? Opposite angles are congruent. Now, the opposite angles congruent really only goes with parallelograms, but the diagonals being perpendicular bisectors of themselves, that goes with a rhombus, and all sides being congruent also goes with a rhombus. Do you understand? Which properties of the diagonals of parallelograms help you to classify? Which properties of the diagonals? Bisected diagonals, congruent diagonals are the main ones. If diagonals are bisected, then there's a chance it's a rectangle or a rhombus or a square. If the diagonals are congruent, it's going to be a rhombus or a rectangle. Let's look at number 2. Sergio was asked to identify D, E, F, G. What was his error? So D, E, F, G. So he said DF is congruent to EG. Oh, okay, that's what we're given. DF is congruent to EG, so we have congruent diagonals. So since DF is congruent to EG, DEFG is a rectangle. Okay, since EG is perpendicular to DF, DEFG is also a rhombus. Okay, that part seems to be good. Therefore, DEFG is a square. Let's see. We got perpendicular bisectors. Okay, and looking back at this, he's not quite got enough in here for this EG perpendicular to DF. You also would have to have that DF is congruent. You would also have to have that DF and EG bisect each other. So do EF and do E to DF and EG bisect. They do, but he's got to bring some more steps out to actually show that they bisect each other, which would mean that these two pieces are congruent because of congruent triangles, and these two pieces are congruent because of congruent triangles. And if they bisect each other and are perpendicular, then that's what makes it a rhombus, which lets him say that it's a square. So there's more work needs to be done on that. So number 3, write a biconditional about the diagonals of rectangles. Okay, so biconditional if and only if. So if and only if a parallelogram has congruent diagonals, it is a parallelogram. I mean, it is a rectangle. Okay, we're going to skip number 4. Let's look at number 5. Is it a parallelogram? Is it a rhombus, square, or a rectangle? So let's see what we got here. Okay, here they're showing us that the diagonals bisect each other. Now, if the diagonals bisect each other, it could be a rhombus, but it's only going to be a rhombus if the diagonals are perpendicular bisectors of each other, and they're not. This has got to be a rectangle. Could it be a square, though? Well, there's not a right angle there that we can see, so it's not a rhombus, and a square is also a rhombus, so this is just merely a rectangle. Here we have that this diagonal bisects the opposite angles. So what does that do for us? 45, 45. That means this is a right angle. And this is a right angle because these have to add up to 180 degrees. And those are complementary. So we have a parallelogram that has all right angles. That's enough to make it a rectangle. But these two triangles are also congruent to each other. So that means that those two sides are congruent and those two sides are congruent. So this is going to be a rhombus because we've got a rectangle that has all congruent sides. So it's a rhombus. Number 7, let's see what we got here. We got these two angles are congruent. So by angle side angle, these two triangles are congruent, which means by corresponding parts, those pieces are going to be congruent also, like this with this one and this with this one. And that is enough for this to be a rhombus. Okay, let's look at number 8. These two pieces are congruent. They're not saying anything about the diagonals being congruent. Now, if they were congruent, that would be enough for it to be a rectangle. Let's see. I don't think we have, okay, vertical angle is going to be there, and there. It's a parallelogram. So with parallelogram, we got alternate interior angles congruent. Let's do 2 marks for those. And going this way, we have alternate interior angles congruent. Let's do 3 for those. So that just gives us angle, angle, angle. So I don't think we can do anything more with that without more information. Now, if you see a better way, let us know. Okay, for number 9, we want to make this into a rhombus. It wants to know what value for x will make it a rhombus. So the diagonals are going to bisect. That's going to be a 36. And if it's a rhombus, there's going to be a right angle there because they're going to be perpendicular bisectors of each other. That's going to be a 90. That gives 126. Altogether, these would have to be 180. And 180 take away 126 gives us 54 degrees. So if x is 54 degrees, this would be a rhombus because that would make this. And then these other angles, this would also be x. This would be the complement, or whatever the pair would be going from the other direction. So, but if x is 54, that would cause this to be a rhombus. So look at number 10. If angle 1 is 36 and angle 2 is 54, is a rhombus or whatever. So let's see. So if angle 1 is a 36, let's see what we can do with it. So with parallelogram 36, this is going to be a 36. Like that. Let's see what else. And angle 2 is 54. Switch colors up. So if this is a 54 by alternate interior angles, this is going to be a 54. Now 54 and 36 adds up to be 90. These are complementary, which means that that has to be a right angle in the center, which means that these are all right angles. So we have diagonals that are perpendicular to each other. And these two triangles are going to be congruent. That means there's a bisection thing going that way, and there's a bisection thing then going this way. So we have diagonals that are perpendicular and bisect with those given angle measures. It also makes them perpendicular bisectors, so that's going to be a rhombus.